Right, so here is the quiz review for sections 9.1 to 9.3. 1/125 to the negative 1/3. Because of that negative exponent, the first thing I'm going to do is cross the line so that I can change the sign of the exponent. And then I'm going to write it with a radical. And the cube root of 125, I think through the fact that it's got to be some number most likely between 2 and 10. And because it ends in a 5, I'm going to start by trying 5. 5 times 5 is 25, times 5 is 125. So the answer is 5. Number 4, 64 to the 4/3. Remember, we always do root and then power. So I've got the cube root of 64, and then I'll raise that to the 4th power. I know it's not 2 times 2 times 2, because that's 8, and 3 times 3 times 3 is 27. 4 times 4 is 16, times 4 is 64. So this would be 4, and then 4 to the 4th. Well, I already know that 4 to the 3rd is 64, so 4 to the 4th would be 64 times another 4. 16, carry the 1, so that's 256. Right, number 2. Log base 16 of 8 equals x. So we have 16 to the x equals 8. So I'm going to write this as I realize if I take 16 and I raise it to a power, it's not going to equal 8. So I'm thinking I need to get the same base, and it needs to be a different base than 16 or 8. So I'm going to try 2. I know that 2 to the 4th is 16, and I know 2 to the 3rd is 8, power to a power. So I'm going to come over to here. I get 2 to the 4x equals 2 to the 3rd. Because they have the same base, I can just say 4x equals 3, so x equals 3/4. Which makes sense. If you take the 4th root of 16, you get 2, and then you cube it, you get 8. Okay, number 5, you've got to remember this is a base 10. This equals x. So 10 to the x equals 0.00, what is that, 1, 2, 3, 4, 5, 6, 5, 6, yeah. So 10 to the x equals 1, and let's see, I know that this is moved over. I guess rather than writing it as a fraction, I can just think, how many times do I need to move this? 1, 2, 3, 4, 5, 6, 7. So I'm going to, since it's 7 places, but it's not getting bigger, it's getting smaller, that would be 10 to the negative 7th. And because it's 1, 2, 3, 4, 5, 6, 7. And since they have the same base, x equals negative 7. Right, let's go to number 3. Got a base of 10 equals x. So 10 to the x equals 1,000. And that's a 10 with 3 zeros, so 10 to the x equals 10 to the 3rd. So x equals 3. So again, I want you to notice the difference between these. Since this has 3 zeros, it's 10 to the 3rd. Here, you're going to look at how many total places this decimal has to be moved over, and that tells you what your exponent is here. And you only have to get to right there. All right, let's go to number 6. Equals x, so we have 125 to the x equals 25. I'm going to write these both with a base of 5. I know that 125 is 5 cubed to the x equals 5 squared. Power to a power, we multiply 5 to the 3x equals 5 squared. They have the same base, so 3x equals 2, so x equals 2 thirds. Number 7, write an equation equivalent to 4 to the 4th equals 256 using logarithms. So log base 4 of 256 equals 4, because 4 to the 4th equals 256. All right, let's look at number 8. Let's write this using positive rational exponents. We would have a to the 16/8, because remember, it's always power over root. B to the 26/8. And of course, I need to reduce my fractions. This would be a 16 over 8 is 2. 26 over 8 would simplify to 13/4. And that's it. I do feel like I still don't feel like I explained number 5 very well. Trying to think of the best way to differentiate between number 5 and number 3. 10 to the 3rd is a 1 with 3 zeros. 10 to the -7th is a 1, and you move back from the 1 7 decimal places. So 1, 2, 3, 4, 5, 6, 7. So that's 10 to the -7th. So think of it as you always start with 1, and it tells you to either add 3 zeros or move from 1 left that many decimal places. Either way, you always start at 1, and you either add 3 decimals or you subtract 7 decimals, or whatever the number happens to be. I don't know if maybe that helps a little bit more. Just wanted to make sure that I'd given you something that was helpful for differentiating between number 3 and 5. I'll even give you another example. If we have, I'll come down here, log of, let's say, 1,000,000, and I ask you what that is, that means we'd have a base of 10 and we put an x, so 10 to the x equals 1,000,000. So that would be 10 to the x equals 10 to the 6th, because it's a 1 with 6 zeros. If, however, I give you log base 10 of 0.001, like that, okay, that means that I have 10 to the x equals 0.001. So if I was to rewrite this, it's a 1, and we go back 1, 2, 3 decimal places, -3. So x equals -3. So hopefully that makes more sense. I don't feel like I explained it well the first time.